Hi everyone. Good evening to all of you. Guys, confirm once that am I audible to or not? All the connected centers kindly confirm once that am I audible to you or not? Hi, good evening Itanagar. Am I audible to you? Confirm once. And yes, wishing you a very happy new year, guys. I hope so. It's a rocking start of the decade 2020 for everyone. Kindly confirm once that am I audible to you or not, so that we can proceed with the syllabus. Okay, so let's start the extraction and purification of the metals. Okay. Before that, we have a recall test. So kindly attempt all these questions. And yes, one more question on the next page as well. So just attempt this question and confirm me once that you have attempted all the questions, so that we will check out the solution part. Okay, do this one as well. Okay, so look at this. Very good. So this was the recall test. Now let's move on to the next section, which is the purification part. Okay. Now there is a small question for us guys, that obviously we have seen such type of materials, or we can say the containers or these designs, okay, in our daily life, that we have seen the gold, aluminum, platinum, copper, lots of things, okay, in the form of the containers or the coins or the jewelries, yeah, many other things. The question is that can we get them as it is, as they look like? For example, a ring of a gold, okay, or we can say a container made up of the copper, okay. The question is that, is it actually that there is a place where we can directly get the gold from there and we just convert them into the desired shape that we actually are looking for? Is that happen actually? This is the biggest question here, okay. So today we have to discuss that, ultimately, that how we can get such type of pure elements, okay, in which forms they will exist in this nature, and how will we get it in this purest form, okay. And that's all has been will be discussed in the section metallurgy, means the extraction or the purification of the metal. So this is the next section for us. Now the basic thing is the occurrence of the metals, that how do they occur in the nature, okay. So basically they occur in the two forms, not the forms, in the two areas. One is your earth crust, okay, and second one is your sea water, or we can say the sea, okay. Generally the pearl is we get it from the sea, okay. So we have to point out the two very important things. First is the mineral and the second is the ore, okay. So let's check out what mineral is. So basically the elements and the compound which occur naturally in the earth crust, okay, are called as the minerals. So these are the elements or the compounds that we will find in the nature. And if you talk about the ores, so ores are basically those minerals which has the very high quantity or the concentration of the particular element in that, okay, so that we can extract that element or the metal and whatever substance is it from that profitably and economically, okay. See, the difference between mineral and the ore is this one, that mineral also contains that element, okay. For example, I talk about the mineral of the gold, okay. So in the mineral of the gold, what will happen, along with the gold will have lots of some other elements, or we can other elements, or we can say the undesired elements or particles from there, okay. Now I have removed those particles, or I can say I have got something in which the percentage or the quantity of the gold was very high, okay. Now that part, or we can say that substance or that arrangement, okay, is now ore, okay. So ore is actually the minerals from which we can get the metals or the elements profitably and economically. This is the basic difference between these two, okay. I hope so you guys have got this one, okay. So first of all, please copy these two things, that what is the difference between mineral and the ore, or we can say how we can define the minerals and the ores, okay. If you are having any doubt or the question, you can please ask me, but before that please copy it. After copying that, please confirm once. Hi, good afternoon, Itanagar. After copying that, kindly confirm once. Copied. Okay, so let's move on. Okay guys, so there are some chemical formulas and the examples of the metals and the ores. Okay, and guys, these are the important part, means these are the important ores and their chemical formulas that you need to remember. Okay, that for iron, the ore is actually the hematite. That is the name of the ore, hematite, and it is a type of ore, oxide. Okay, mainly we can have the oxide in the sulfide ores. And another one is your iron pyrite, then copper pyrite, which contains the copper, then copper glance, which is CuS or Cu2S. Okay, it is a type of sulfide ore. Then aluminium in the form of bauxite, galena is PbS, this is for the lead, and then litharge is also for the lead, and the pyrolusite for the manganese. Okay, so all these metals and their ores you have to remember. These are very important. Okay, and we'll discuss that how we will get these metals from these ores. So first of all, copy this one, and after copying that, confirm once, everyone. Copied. Okay. Done. Can you move on to the next part? Hey, hi, good evening, or Shillong. Okay, so let's move on. Oh guys, now this is the very important chart for us. Okay, the whole refining, or we can say not refining, or the whole extraction of the metal from the zero to the top. How we can extract, or we can say that what is exact process for the extraction of the metal is given here. That chart should be memorized to you. Okay, you have to remember it. Okay. And yes, we will discuss each and every step in detail after that. So let's start with this chart. That first of all, we will have a ore. Okay, ore is something from which we can get the metals profitably and economically. Okay, after that we concentrate the ore. Okay, and for the concentration we can have some methods. Okay, like crushing or grinding, or we can say removal of the undesired impurities. Okay. Then after concentration, after removing of the undesired impurities, like they are generally known as the gangue. Okay, gangue means the dust particles or sand particles, or we can say the stone particles, or whatever the waste things. Okay, which are not useful to us will be removed in the concentration section. After that, after concentration, we will divide, or not divide, actually we will find out that from which in which category that particular type of ore can be fit. Means it might contain the metal of the high reactivity, it might contain the metal of the medium reactivity, and it might contain metal which has the very high reactivity. Okay, so after getting this information, we will further process. Okay, so if the metal is having the high reactivity, in that case we generally use the electrolysis, or after that we will get the pure metal. Okay, so for the high reactivity we have to use the electrolysis process. Okay, now let's move on to the part number 2, which is the medium reactivity. In case of the medium reactivity, we need to check out whether it is the part of the carbonate ore or it is a part of the sulfide ore. Means in the medium reactivity we have the two types of ores, carbonate or the sulfide. Now if we are having the carbonate ore, we will process further by a method which is known as the calcination. Yes, what calcination is, we will discuss about it later on. And if it is the sulfide ore, then we will have to do the roasting. Okay, and after calcination and the roasting, we will have the oxide of the metal. Okay, after getting the oxide, we will reduce that oxide to the metal, and after that final process, which is the purification. Okay. Now, if we talk about the low reactivity, in case of the low reactivity, it is generally the sulfide ore. Okay. See, sulfide ore can be of the two types, medium reactivity and the least reactivity, which is very low reactivity. Okay. So remember, in both the cases, we have to follow something different steps. Okay. In case of the sulfide ore of the low reactivity, we have to perform the roasting, and after the roasting, we will have a metal. But yes, along with the metal, we will have a certain different metals as well. So we have to refine that. That's the difference. Okay, we have to refine that. Okay, and after refining, we will have the pure metal. Okay, so this is the whole flow chart of the extraction. I hope so it is clear to everyone. Okay, so if you are having any doubt, first of all, copy it. Yes, I have to discuss each and every point in detail. After this, we are going to start that. And yes, before that, if you are having any doubt, you can please ask me. But before that, please copy it. Copy and then confirm. Okay. Itanagar, have you copied that? Or you need some more time? Okay. So guys, this is the reactivity series. Okay. We need to learn it because these are the only important elements that we need to remember. Potassium is the most reactive among all these. Okay, means these are the elements whose extraction we have to cover. Okay, potassium is the most active, and then slowly reactivity has been decreasing, like potassium, sodium, calcium, magnesium, aluminium, zinc, and at the last we will get the gold. Gold is the least reactive element. Okay, so this is determined experimentally, and that we have to remember that this is the reactivity series. So I'll suggest please remember it, and yes, try to practice in written for the better memory. So first of all, copy it, and after that just inform me once. Copy please. Okay. Done? 8 turn ago? Okay, so let's move on. Okay, so this is the brief information that where we can get these elements. First one is the metals at the bottom of the activity series are the least reactive. They are often found in the free state. Okay. For example, the gold, silver, platinum. Free state as in they won't be combined with other elements. Okay. Whereas the second, which are the moderately, not mod, these are the reactive, very reactive. So they will never found in the free state, they will always be combined with other elements, other substances, whatever they get, okay, they will be in the combined form with that. And then in the middle of the series, they are generally found in the form of the oxides, sulfides and the carbonates, okay. Uh, because that makes them little bit more stable, that's why they will get combined with them, okay. So this is the general brief idea that how we can get these elements in the nature. So please copy it once, and if you want to ask me anything, please go ahead, you're most welcome. Don't feel shy anything to ask, okay, I mean questions, okay. So copy and then confirm. Okay. I'm getting it, Itanaga. If they are not combined, can't we get them directly without refining? No. Combine as in they won't be combined with the other metals or other elements. Okay, that's the meaning of the combining. For example, gold won't be in the form of the oxide, or we can say the gold won't be in the will not form the compound with the potassium, sodium or zinc. Okay, but yes, gold can be found with the undesired impurities like we can say the gangue particles, which are what, stone particles or dust particles and many other things. Okay, so majorly a free state as in they won't be connected to other metals. Okay, that is the meaning of that. And other than that, yes, they will have something. Okay, and we need to refine that, we need to remove that. Okay. Copy. Okay. Okay, first section is extracting metals low in the reactivity series. Okay, examples are the gold, copper, silver, or platinum. Okay, that most metals are found naturally in the rocks called the ores. They are in the compounds chemically bonded to other elements. However, unreactive metals at the bottom of reactive series can be found as the elements themselves, means as individual elements. Okay, and that's why we say that they are found in the native. Native means their natural state, their pure state. Pure as in not exactly the gold. Okay, means yes, definitely some undesired impurities will be there. Okay, but in very less quantity. So first of all, copy this one, and after that we will move on. Which metals are found near to earth crust is low reactive? See, this is not the specific reasons where you will get only the highly reactive, least reactive, or the most reactive. Okay, they are not the very specified reasons. Okay. But yes, there is a section where you can get these metals, or we can say ores of these metals. Okay, but on that they will have the specific quantities of them. I'm just trying to say that there is not a specific layer that we will say that in this layer you will get only the most reactive, only the least reactive, or the only the medium reactive. Okay, this is we can't say. See, first of all, the diamond is actually been converted from the carbon, and that is not the purest form. Purest as in that a diamond is being prepared, it is an allotrope of the carbon. Okay, when carbon, which is a graphite, is subjected to very intense high pressure and the heat, after that that form is converted into the diamond. Okay. Yes, copper forms compounds, na? Who says it does not form the compounds? See, copper pyrite is its ore, na? No, no. See, ore doesn't mean that it will have only that element. Ore doesn't mean that. Copied? Are you clear with your point, Itanaga? Okay. See, when you check out the copper, na, check out the copper pyrite. Here you get the Fe and S2 along with the copper. Okay, so it means that ore is something that will contain such composition, and from where we can remove these elements. Okay, means from where extraction is very easy. That's the native exactly means. Okay, even if you talk about the gold, you won't get it in the pure state, means only the gold, no, it is not possible. Okay, try to understand that. Native means, yes, it can be present with very a few little elements, with other elements. Okay, and if still it's not clear to you, Itanaga, then kindly rewrite your question. The question that I can see on the screen, on the basis of that I have given answer to you, and if still it's not clear to you, then kindly write the question if you are having any doubt. Okay, and yes, the next is, yes, check out this one. Heating of cinema, which is the ore of the mercury, in the presence of air, is first converted to the mercury oxide and then converted into the mercury. See, HGS is first converted into the HGO, and after that, on heating HGO, we will get what? Pure Hg. Okay, so this is a very easy method to get the elements. Check out the copper. We have to just heat that Cu2s. It will be converted into the Cu2O, which is the oxide, and after that just treat it with the Cu2s again, and we will have what? Copper. Okay, so these are the important reactions, and yes guys, reactions have the importance here, so kindly copy it and then confirm once. Okay, so you are saying yes, gold. Yes, gold can be get in the combined state of the other element as well in the form of the alloys actually. Okay. Like you can get the gold along with the silver. Okay. Copied. Now, extracting metals in the middle of the activity series. Okay. So there are the few steps as well that we need to follow while extraction of these metals. These are usually present in as a sulfide or the carbonate in the nature. It is easier to obtain a metal from its oxide as compared to its sulfide and carbonate. You are saying that Cu2s is in which state? If you are getting it from the mining, then it will be in the solid state initially. Then you will change its state. Okay. So these are the few steps actually. First, conversion of metal sulfide and carbonates into the metal oxides, and after that the metal oxides and then reduced to the corresponding metals by using the suitable reducing agent. Generally we use the carbon in general. Carbon monoxide can also be used over there, but carbon is very common, so we'll talk about the carbon. Okay. And after that, besides the carbon, we can use some displacement reactions also. So we'll discuss about the displacement reactions after this. So first of all, you have to copy this one. Again, these are the steps that we need to follow. We can say we need to remember. Okay. So please copy and then confirm. Are you clear now? Itanagar? Copy and then confirm. Copied. Okay, so let's move on. Okay, the point is how roasting and calcination are different from each other. Roasting is basically heating of the ore in the excess of the air. Okay, 1 second, 1 minute everyone. Okay, Itanagar, copy please. Confirm once after copying that. Roasting is heating of the ore in the excess of the air. Calcination is in the absence. Absence doesn't mean that there will be no air. It means that there is a very limited supply of the air. That means the absence. Okay. Then it is used for the sulfide ores, whereas the calcination is being used for the carbonate ores. Okay. And in the roasting, we will have the SO2 along with the metal oxide, whereas in case of the calcination we will have the CO2 along with the metal oxide. Okay, and here we have given with the given examples as well, that like when we heat the ZnS we will have the ZnO along with the SO2, and if we heat the zinc carbonate we will have the zinc oxide with the CO2. Okay, so there is a difference between calcination and the roasting, again a very important part. So copy please and then confirm once. Copy and then confirm. Shillong, Itanagar, guys, have you copied that? You are saying, is it possible to get metal from all metal oxides by the process of refining? Not always we need the refining. Not always. Like we can get the aluminium from aluminum oxide by the help of electrolysis. No refining needed. Okay. Yes, refining is one of the major uh, major step that we take in most of the extraction part. Okay, but you can't say for the every element. Okay, so let's move on. I hope so it is clear, Itanaga. Okay, so guys, there are some examples as well, that extraction of the zinc. Okay, this is the whole process to get the zinc. First is conversion into the oxide. We can do it in the two ways. That first is the roasting, and second one is your calcination. Okay, and after that we have to reduce the zinc oxide by the help of carbon. We will get the zinc over there. So this is the process that how by which we can get the zinc over there. So kindly copy it, and after copying that, confirm once. Okay, let's move on. This is a displacement reaction, guys, that conversion of metal oxide with the help of displacement reaction. Examples is given for the manganese and the Fe. That when we treat the MnO2 with aluminium, we will have the Mn. There is a simple displacement reaction. I hope so you have knowledge about this displacement reaction, where the elements just gets change their position with the other elements in a compound. Similarly, check out the second part, where Fe2O3 is again being treated with the aluminium, and we have got the Fe. Okay, and these are the example of the displacement reaction that you need to remember. Means that this is a section, guys, where we have to remember lots of things in the current chapter. Okay, in the next chapter, which is a carbon and its compound in the periodic table, we have lots of things to understand. Okay, so that chapter is quite interesting actually. Okay, but here you need to remember few reactions. So yes, I'll try that we will wind up this chapter by today, so that in the next class we'll start with the carbon and its compound, and after that we will have a periodic table. And yes, guys, very important chapter for your higher classes as well, like class 11th or 12th. Very important. It is like these are the basic that you need to develop before that higher classes. And yes, please copy and then confirm. Mg and Fe. First of all, that is Mn, not Mg. Yes, they are in the they are in the molten state. Manganese, not magnesium. They are in the molten state. They are not miscible with each other, no? And further we need to follow some other steps as well. And one more thing, that aluminum oxide is in the solid state, whereas the Mn and the Fe is in the liquid state, which is the molten state. So obviously whatever solid part is there will be settled at the bottom, we can say, or we can say that solid part will float over that molten state. Okay, means they will have the separate layers over there, and you can get them. Means whatever molten part is there, we will just put some, what we say that, some outlet over there from which we can get out that molten part, and solid will can remain inside that. Okay, so that is also that is a part of the refining actually. Got it? A thermite reaction, very important guys for the exams, that the reaction of iron 3 oxide, which is the Fe2O3 with the aluminium, is used to join railway tracks. Okay, just because it produces a very high intensity, okay, railway tracks or cracked machine parts. Okay, this reaction is known as a thermite reaction. Thermite stands for the word thermite is been given over there is because of that high intensity. Okay, because therm means the heat. This is the reaction over there, that Fe2O3 with aluminium will give you Fe with Al2O3, and the plus H heat written is over there. It means that during this reaction heat is being evolved. Okay, this reaction is displacement reaction and evolve high amount of heat. Okay, and then high amount of heat is actually helps in joining that cracked part. Okay, if you have seen the welding anywhere in your life, if you have seen the welding, okay, see in the welding we use the hydrogen actually over there, means that the chemical reaction is totally different, but I'm just relating it. Okay, even we in the welding section we do the same thing. Okay, the kind of same thing. Copy and then confirm. Iron 3 means it is representation of the charge, oxidation state. That iron is in +3 oxidation state. Or we can say in the compound Fe2O3, Fe will have +3 charge. copied. Okay, so let's move on. This is the extracting metals in the top of the reactivity series, that is by the help of the electrolysis. Okay, highly reactive metals are obtained by the electrolytic reduction. Most metals are obtained by electrolysis if of their molten state. Metals are deposited at the cathode, the negatively charged electrode, whereas the chlorine gas is liberated at the anode. This is specifically, guys, the extraction of the sodium, means how we can get the sodium. Okay, so this flow chart, or we can say these steps, are specifically saying that we are obtaining the sodium. One second, guys, 1 second. This is the setup for that, guys. This is the setup. Look at this. This is your electrolytic cell. In the electrolytic cell, we have filled the molten NaCl. First of all, you have to draw this diagram, and after that you have to copy those steps. Okay. We have dipped the 2 electrodes into it. Now what's happening actually, that NaCl first of all will get dissociated to give the Na plus and the Cl minus, and slowly what will happen, that the Na plus will get deposited on the negative electrode, which is the cathode. How it will deposit? See, look at the diagram very carefully, that the cathode is a negatively charged electrode and Na plus will carry the positive charge. So what's happening, that the positive charge will migrate towards the negative electrode, just because we know that the opposite attracts. So just because they are having the opposite nature of the charge, they will attract each other, and once the Na plus will get in contact with the cathode electrode, it will simply get deposited over there, and slowly the rod will become thicker. Okay, and that thickness, or we can say the extra layer, is representing the copper, means we are not copper, sorry, we are getting the sodium. Okay, similarly the Cl minus will move towards the anode part, and it will be, there will reduction process, and Cl negative will get converted into the Cl2. Okay, so here you can see in this diagram we will have this Na and the Cl2. Okay, so first of all copy this diagram, and after that we have to copy those steps. No, it's not like magnet actually. You can't say it's a magnet. It's like simply the charged particles. Guys, please copy and then confirm. Positive attracts or reverse? I'm not getting your questions, Shilong. So I'm just saying that cathode is a negative terminal and anode is the positive terminal. And just because Na plus and Cl minus is having the opposite charges, so they will move towards those electrodes which are having the opposite charges, which are already present on the ions, Na plus or the Cl minus. Means positive electrode will attract the negative ion, and negative electrode will attract the positive ion. What I'm saying? I hope so it is clear to you. Means you have got the answer for your question. If still not, then you can please rewrite your question, because I'm not getting your question clearly. Copy and then confirm, guys. You are saying which acts like a magnet. Yes, you can say it's act like a magnet, but it's not a magnet. What I'm trying to say. See, being a like is something different, and being exactly same is something different. You can say it's like that. Okay, like North Pole and South Pole attract each other just because they are having the opposite nature. Okay, but you won't say it's a magnet. This is not magnet. These are simply the charges. Have you copied, guys? There is no water here. We are just having the molten NaCl. No water. If water is also there, then the reaction would be different. Okay, means water will also be the participant over there. Okay, that is not in the syllabus right now. That is in the higher classes. Yes, they work on the same principle, dear. This is for the Shillong. They work on the same principle. Guys, now please copy this one. These steps. Copy and then confirm. After copying that, confirm. Need not to copy this diagram, guys. You have already drawn it. The previous diagram. You have to remember that diagram only. No, because hydrocarbons are non-polar in nature. We need the polar substances, as in those substances which are having the ionic bond, or we can say the ionic nature. Hydrocarbons are non-polar, means they are not ionic, they are the covalent compounds. You can't separate them. If you want to separate, just heat them. After heating that, you will get the water and the CO2. Simple. Yes, you can electrolyze water, no? Who says you can't electrolyze water? It is polar. Yes, you can electrolyze it. And after electrolysis, you will get the hydrogen and the oxygen. It's possible to electrolyze the water. Okay? I hope so everyone has copied that. So let's move on to the next part, guys. The next part is the refining of the metals. Okay, after getting the oxides just of the few processes, we are moving towards the refining section. Metals produced after the extraction process contains impurities which must be removed to obtain the finally pure metal. The process of this one is known as what? Refining. Okay, so there are a few methods as well over there, so we will use them, but before that copy this one, copy and then confirm. Okay, let's move on. Electrolytic refining. So many metals like zinc, tin, nickel, silver, gold, etc. can be refined by this method. Okay, in this process, impure metal is taken as the anode. Okay, guys, I'll suggest that please copy these points, and with the help of an example, I'll clear all these points. Okay, so just please copy it. Just copy it. Don't worry. I'll discuss all the point with the help of one example. Copy and then confirm quickly. Guys, confirm once after copying that. Okay, let's start. See, this is your setup. One second, guys. Do not draw it. First of all, just understand the meaning of this one. Okay. Let's consider we are using the copper. Okay. So this is your copper, and this is your also copper. But this is the electrolytic solution. This is your anode, which is positive, and this is cathode, which is negative. And check out this one, anode. This is your cathode. So the point is, whatever means the elements whose purification you have to process, just make it as an anode. Okay, because at the anode part there is an oxidation process. So actually, what happens in the oxidation, that the rod, which is the electrode of the anode, will actually get electrolyzed, means will get oxidized to give you what, Cu2 plus with 2 electrons. See, I am typically talking about the copper, refining of the copper. Okay, so actually what's happening, that this rod is converting into Cu2 plus ions and giving the 2 electrons. Okay, so what will happen, that slowly this rod will start decaying. Okay, and it will produce the Cu2 plus ions. So what will happen, these Cu2 plus ions will migrate towards the anode, towards the cathode part, and it will start depositing over there, because this is negative terminal. Okay, and we will have a thick additional layer, and that additional layer will be of what, copper. And this rod will actually be oxidized like this. See, it will slowly become thinner. Okay, and obviously whatever impurities are there will be settled here like this. Okay, and this is known as what, anode mud. Okay, so this is what the process of the electrolytic refining. Kindly confirm once, are you clear with this one? Kindly confirm, everyone, are you clear with this one? This is the electrolytic refining. You have written all of these things in your notebook as well. This is just a concept. Please copy and then confirm. Everyone, please copy and then confirm. Please copy and then confirm. Yes, definitely. First copy it. Copy and then confirm. Okay, so let's start. See, actually what I was saying, that the metal that we have to be purified, just make it as an anode. Okay, why we have making it as an anode? Because at the anode part there is oxidation process. Okay, so what will happen, the rod which is being of that metal will actually be oxidized to give you what? Positive ions. Okay, now what will happen, these positive ions will migrate towards the cathode. Okay, just because you can see in the diagram that the cathode is negative terminal, as we have discussed earlier in the electrolysis process, that if they are having the opposite charge, they will just get neutralized by interacting with each other. Similarly, here the copper will interact with the negative terminal and will simply get deposited over there. Okay, and you can check out the thick layer over there. That additional thick layer is of the new copper, means the new pure copper over there. Okay, so this is how you can get the pure element by the electrolytic refining. Okay, if let's say suppose you want to purify the zinc, so just make zinc as an anode. Okay, if you want to make the zinc as a if you want to purify the zinc, make it as an anode. Okay, remember, between anode and cathode, only anode, means at the anode part you have to put that element which you have to purify. If you put it at the cathode, it won't be purified, because cathode will be act as an electrode which is simply being used to just deposit that metal. That's it. Okay, if you would like to purify the silver, then simply make it as a anode. If you would like to purify some other element, consider anyone which you would like to be purify, make it as anode. Okay, and that part will simply get deposited over the cathode, and other than that, whatever additional impurities are there will simply be settled down at the bottom, and that impurities part is known as what? Anode mud. Why it is the anode mud? Because these impurities have been prepared, or we can say we are getting it from the anode. That's why this is known as the anode mud. Okay, I hope so now it's clear to you, Itanagar. If you are still having some doubt, please just let me know. Okay, I can show you another diagram based on this one. Please confirm it once. Done? Okay guys, this is the question for you. Please read the question carefully and then answer it. Tell me the answer for this question. See, anode mud is simply the name just because mud is something which is not usable over there, means which is not getting deposited over there. It is, it do not have any relation with that reactivity part. Okay, it's like that I would like to obtain the copper. Okay, so if I'm getting the copper from the anode, that is my important metal, or we can say my important part that I was looking for. Okay, and other than that, either I'm having the gold, platinum, silver, whatever it is, I'll simply call it as a undesired part, which is what? Mud simply. Okay, so this mud is actually referring something which is like that. I'm not trying to getting that. Okay, that's why I'm saying it is anode mud. No other reasons behind that. Got it? Okay, you have given your answer. Itanagar, have you attempted this question? Okay, but answer is C. Okay, let's read the question. Student has altered the experiment condition for obtaining the pure sodium metal by electrolysis. Instead of using molten NaCl, he used the aqueous NaCl. Cool. What do you think the results of his experiment? Yes, no sodium will be obtained, because in spite of the sodium we will have the hydrogen gas. Okay, this is actually the decision is based on the electrochemical series. Okay, hydrogen is more reactive over there, that's why we will get the hydrogen in spite of the sodium. Okay, I guess this should be given over there. See, the detailed explanation is actually in your higher classes. Okay, or you can simply remember it. If you use the aqueous NaCl, you won't get the sodium, you will get the hydrogen. You can simply mention it in your notebook that if we use the aqueous NaCl, we won't get sodium, we will get the hydrogen in spite of the sodium. Okay, so that's all about. If you use the molten NaCl, then we will get the sodium. Do you remember that if someone was asking me that, sir, what will happen to water? We are using water also there. I said no, there is only molten NaCl, no water is there. If we use the water, then there will be something different reaction. Okay, so that is the different reaction. If we use the water, that water will also be participant over there. Okay, and after participating it actually replaces the sodium to get deposited. Okay, means at the place of sodium, hydrogen makes its position because of its high reactivity. Okay, and we get the hydrogen in spite of the sodium. Okay, so guys, that's all about this chapter. Yes, hydrogen gas will be produced over there. Okay, hydrogen will be produced from the H plus ions. See, in the competition, look at the third line where the ions are written over there. That however, when the aqueous NaCl used, we have 4 ions. We have 4 ions: H plus, OH minus, Na plus, and the Cl minus. So there is a competition between H plus ions and the Na plus ions. Okay, and in the competition of the electrochemical series, H plus wins. Okay, and H plus is the winner in the form of the reactivity. That's why H plus gets a chance to get reduced, and that's why we get the hydrogen. Okay, I hope so it is clear to you. Got it? Okay, cool. So guys, that's all about this third chapter. We have winded up. In the next class, we will start with the very interesting chapter, which is carbon and its compound, and after that the periodic table. Okay, so I'll see you next time, guys. Thank you so much. Take care of yourself. Bye bye. Good night.